So my name is Alan Renouf. I am a senior product line manager at VMware. I focus on the APIs, SDKs, and CLIs in the cloud platform business unit. So vSphere, all the surrounding products around that, making sure that we do what's right from the APIs, but also the developer interfaces and the documentation and the complete API lifecycle. As well as that, I'm also working on the automation initiative for VMware Cloud on AWS. So making sure we, again, do exactly what the right things are for our customers from the point of the developer and anyone that wants to integrate or automate the features that are in VMware Cloud on AWS. So I'm presenting today with Alex Josh. Alex.
All right, so just a quick overview of what we've been doing on VMware Cloud on AWS. My name is Alex Josh, and I'm a product manager on the core team. Just a quick disclaimer, standard rules apply. We do take these things very seriously, so we'd appreciate you following the rules. If you don't, then we don't get to tell you cool stuff. So even though we show the slide every single time, it's still important. All right, so what we're going to do is we're going to get into just a quick discussion of what VMC is and how it works. For those of you that have seen this 15 times, we'll keep it pretty short, but some of you might not have had a chance to walk through the product yet, so we'll kind of go over the basics, talk about what it is and how it works, and then we'll get into the cool stuff. At its most fundamental level, VMware Cloud on AWS is a managed service that's sold and delivered by us. We developed it in partnership with AWS, a ton of engineering work on both sides, but in the end it's our product and we deliver it. So you buy it from us, and it's a subscription-based service. In effect, what you're doing is you're renting ESXi hosts in the cloud from us by the hour. There's a lot more to it than that, but that's the basics. What we do is we get a bare metal physical instance from AWS running in their data center. There was some question about this week, apparently. A couple of sessions, somebody said the wrong thing, and let me make it like super clear, right? This is not nested. This is not running on Zen. This is not traditional EC2 instances. We're talking about bare metal Intel motherboards with Intel chipsets and the whole schmeal, right? ESXi is the hypervisor. There is no other hypervisor. So we take that bare metal instance, we put ESXi on top of that, then we put vCenter on top of that to manage it, and along with the show you get vSAN and you get NSX. All of this comes together, pre-managed, pre-delivered by us, installed by us, operated by us. There's no licensing involved. You do not have to license these servers. Support is 100% included. There's an hourly subscription charge for the running hours of your ESXi hosts, right? And actually pricing is up on our website if you want to get into that kind of stuff. The minimum host size that we support, cluster size we support, is 4 minimum. And then you can grow that up to 8 or 16. Later we'll be going to 32 nodes, and beyond that you'll be able to put multiple clusters in a single SDDC. So a single SDDC can become quite large, right? Potentially hundreds of hosts. This sits inside of an AWS data center, but it's still vSphere, it's core vSphere. It's not like vCloud Air. You're not using VCD. You're just running vSphere. What that means is that you can phone home back to your on-premise environment using what we call hybrid link mode. Hybrid link mode is just link mode, which you probably already know what that is, but it allows us to come down from the cloud and do link mode from the cloud into your data center on-prem. So now you have a single UI where you're managing the cloud and on-prem in a single merged vCenter experience. So that's the arrow that's going this way. On the other hand, we're also sitting inside of an AWS data center. So what this means is that because of the way we configure the network, you have very low latency, high bandwidth access to native, what we call native AWS services, like EC2, for example, which we are not, right? And S3 and RDS and all those other things. The way we construct the network is that we take a VPC that we manage, and that's where your ESXi hosts live, and then we take a VPC that you manage, that is to say your account, and we connect those accounts together. In order to do that, you have to delegate some permissions to us, and we give you a CloudFormation template that allows you to do that. It's pretty simple. And once you've done that, we go in and we create ENIs in your VPC. And then we mount those ENIs on our hosts. Now what happens is that we are participating natively in your network. This is what allows us to have basically an L3 routed connection from a VM running on vSphere directly into, say, RDS. No transit fees, you're not going across an AZ boundary, you're not going from VPC to VPC, there's no VPC peering involved, right? It's a native ENI. And that's what that other arrow is. Make sense? And then on top of that, then you put all your traditional things like VROPS or VRA or any other things you want to run. It'll just work. Why? Because we're vSphere, we're vCenter. Nothing special, nothing magical. Because it's sold as a service, the implication here is that we are fully and completely responsible for ESXi and vCenter and NSX. And in fact, you cannot, as a customer, log into an ESXi host. You cannot patch them, you cannot shut them down, you cannot turn them on, you cannot turn them off. That's our responsibility, and if something goes wrong, it's our problem and we'll fix it. What you are responsible for is the guests, the VMs. So you still have to do things like capacity management, right? You still have to patch the guests and all that kind of stuff. So there's no restriction on what you can run, but you're running in a lowered permissions model from on-prem. So that's probably the biggest difference that you're going to find, is that you're not logged in as root. And that means there's some things you can't do, and especially when we get into the API portion of the talk, you'll see that you may have to modify some of your scripts and approach this in a slightly different way. The goal here is to allow you to do everything that you want to do against the VMs, but put you in a permissions model that kind of protects you from making terminal errors, right? So for example, you don't want to stop VC, right? That shouldn't be allowed. We don't allow you to turn VC's HA settings off, right? Because if the host dies, VC has to start. So those kinds of things are restricted, and you're not allowed to change them. The implication also is that you can't push VIBs or other custom code into ESXi. Right? We control the patch level of ESXi because we're responsible for the stability of the server. If you were going to install like a random VIB on ESXi, put it in community support mode, who knows if ESXi is going to run or not? That's not the way this service works, right? So there's a give-get here. So you give up some control, but what you get is you get a fully running system, a fully running vSphere environment with basically no effort. The implication here is that we're also responsible for things like hardware failures. So traditionally, what most customers do on premise is they under provision by 25, 30%. And the reason why most people do that is, well, if you have a failure, you want to make sure your VMs keep running. You can continue to do that here in the cloud, but you may want to reconsider. And the reason is because when you have a hardware failure, instead of having, opening a ticket and having a technician go and rack and stack something, what actually happens is the automated system kicks in and automatically reprovisions an additional host into your cluster. And I have a demo of this that I can show you a little later. I don't think I have time to do it at the moment, but you can grab me offline. And it's about 10 minutes from when we first noticed the problem until we're fully remediated with a brand new host. So because of that, our expectation is you're probably going to be running these clusters a lot hotter than you run your clusters on premise, right? Instead of running at 30, 40, 50% utilization, you're probably going to be running at 80, 90% utilization. The other thing is a lot of people run their clusters cold for capacity reasons, right? When I buy a rack of gear, I make sure I buy it nice and big so that I've got some headroom so I can grow over the next couple of years. In this scenario, that's not necessary, right? If I want to add a host, it's only a 10-minute operation. So why would I have 5 hosts running when I only have 4 hosts worth of workload? So there's this capacity management and scaling exercise that you have to do, and that's something that you're responsible for as the operator of the SDDC. Make sense? Split accountability. Server down, our problem. Ran out of capacity, that's your problem. You go add a host. The other thing is that the way that we set this up is we've broken it up into a management pool and a compute pool. So the idea is there's a resource pool that is delegated to you that's called the compute resource pool. You have full privileges to do whatever you want in there. In the management pool, you can see it, but you're a read-only admin. So basically all the things that are in blue here are managed by us, visible to you, but cannot be changed. It's read-only. And then basically what you get is the green part, which is your resource pool and your VMs, and obviously patching and managing the guest OS inside those VMs. So I tried to do that super quick because I want to get to all the good stuff. So happy to answer questions later if I went a little bit too fast.
So Alex gave us a really good overview of VMware Cloud on AWS. So I'm going to dig a little bit deeper and tell you what that actually means when it comes to automation and integration and the kind of some of the things that you might need to know if you're looking to automate or integrate with this service itself. You know, Alex clearly spoke about the restrictions that we've given you, or I would say the benefits, because you no longer need to install vCenter or install the ESX hosts and manage those. That really does come down to our responsibility. But you actually work on what you care about, which is the VMs and managing the VMs and the applications and the OSs inside of those. So I'm going to talk first of all about the API endpoints in VMC and then break into each one of those and then do a few demos. We're going to end up today with a pretty cool integration demo that was written internally at a hackathon that we had in a day and a half. So I'll show you exactly how I use these APIs in a day and a half to achieve something pretty special, and hence the equipment on stage. I think you can probably guess what it's going to be given the keynote on Monday. And no, it's not an interpretive dance.
Wait, what?
Sorry, Alex, you're doing the interpretive dance.
Oh.
So it's broken down, the APIs are actually broken down into 3 different areas. As was mentioned in the keynote this week, there's multiple services coming out from VMware in the cloud. These are all under the console.cloud.vmware.com endpoint. So these will give you access to the APIs for all of the services that are available under that area to actually manage the different areas. We'll go into these in a bit more detail in a moment. I'll tell you exactly what's under there and what you can use in each one of these areas. The basics of it are that all the APIs are REST-based APIs. They all work with the modern kind of HTTP verbs that you would expect from a RESTful API. I'm sure most of you are already using REST APIs with other products and with cloud products as well. So hopefully you're used to these areas and are getting started to learn these if not. We clearly have a JSON input and a JSON output, and we use OAuth to actually authenticate to these different APIs so that you can access the information in there. The documentation is provided inline and online, and I will show you actually examples of what that means in a moment. The 3 different areas that I'm going to break into in a moment is the console-based stuff, which I said was the service, managing all of the software, the SaaS-based services from VMware. And then we get a little bit more specific and talk about what features of VMC we actually want to manage, VMware Cloud on AWS. At that point, we'll go over to the VMC endpoint, and I'll show you exactly what's in there, what you can do there. And then, of course, as Alex mentioned, at the end of the day, what you're doing is deploying a software-defined data center. So all of the APIs that you're used to and that you know already, all the ways that you manage those and you know already, are available to you as part of the vCenter server itself. So again, I'll show you that area and we'll break that down a little bit more and talk about how we're enhancing that in the core product. So when it comes to the console APIs, focusing on these first of all for all of the SaaS-based systems, there's a few examples of the actual APIs here and the endpoints that you might hit and some key ones that you can access. So I put these on the slide here. There's links to them as well. All of these slides are going to be available after VMworld for you to be able to download in the VMworld site, as well as a video of this. And you're going to be able to click on each one of these and actually go to the API endpoint live, the documentation that's in there, and be able to work with these to do things like invite a user to your org, remove a user from your org. As you start using VMware Cloud on AWS, all of these APIs will become relevant to you, and you'll want to do this kind of stuff and automate it and maybe integrate it into the services that you produce on top if you're a partner. Going one step further down into the VMC API endpoint, we can see that we actually have a vmc.vmware.com/vmc/API. So this is where the API exists for the VMC endpoint, and then you'll be able to bring this up. It's currently in a technical preview mode. So what that means is you can use it, but it may change in the future. The reason it may change in the future is because we want your feedback. We want you to use this. We want you to tell us if something isn't right or if we need to make adjustments so that we can do these while it's in a technical preview mode and then give it you as a full working solution where you can guarantee backwards compatibility of that API. The API endpoint, I'll give you demonstrations of this in a moment, but it's there to do things like create the SDDC. So all the items that you'll see, if you've seen any of the VMC demos, like the one that you saw in the keynote, where they go into the UI and they create an SDDC, these are all available via the API. So being able to create and remove the SDDC, add or remove a host, work with things like Elastic DRS, list the organizations, the SDDCs, the tasks that have taken place in your VMC environment. All of these are available via the API, as I said. They're accessible via something called access tokens. I'll show you exactly how to use these in a moment and where to get these from. But once you have these access tokens, you can give yourself access to the API and start using that API in whatever way you want, whether that's CLI, whether that's through the API Explorer, or whether that's through an SDK. The VMC API Explorer is just one of these ways to use that API. You can see we can log into this API Explorer and we can actually put our access token in there. I'll give you a demonstration of this in a moment. And we can use this API Explorer to actually browse the things that we can work with in there and understand the model of the API. We can use it to actually live try out the API as well on the service. So why don't we actually take a look at some of the key API endpoints that we might use in this area. So we're focusing on the VMC service, as I said. So some of these might be to provision an SDDC. So in this case, we would go to the API that does that. We would go into orgs and then put the org ID in SDDCs. We would see some create, some list, some get type stuff, and you'd be able to call these APIs and create an SDDC with a single API call. You'd also be able to work with the ESX hosts and some of the DNS and some of the other settings in there. Let's go through this API Explorer demo, and I'll actually show you this working. So as you can see, I'm logged in as myself at the moment into VMware Cloud on AWS. I've gone to the access tokens page, and you can see here I've already created myself an access token. I'm going to regenerate that now. So we can regenerate that to make sure that that access token is no longer used and I get a new one. And now I'm just going to copy the access token itself, the refresh token, to the clipboard. And you can see I'm going to go to the VMC service, and actually I'm going to go to the API Explorer that's available as part of the VMC service. I can click the authorize button at the top, and I can actually give it that refresh token that I gained before. And now as we go through, we can see all of the features available to us as part of the VMware Cloud on AWS service and how we might work with those through the API. For example, if we wanted to get a list of the organizations, we could go to a get on /orgs, and we can even try it out. Once we've tried it out, we'll get the most basic format back, being a curl command, and it'll also give us the response in a JSON body that tells us exactly what we've got as our organization. So all of the data about the organization is stored here. You can pull this, you can start working with it in your various tools. This is just a REST representation of what that looks like, and the JSON body. You can see I'm going to copy the ID here for one of our for one of our organizations, and now we're actually going to go and list the SDDCs available in that organization. So we can go to /orgs, we can put the ID in for our organization, which we got a moment ago, and then when we go and try it out, it will list us all of the software-defined data centers that have been provisioned in this organization. So you can see how it's very easy to start exploring this API and start learning this API just by grabbing your access token from the main portal, coming into the API Explorer, and seeing the information available to you. This is a great learning aid and gets you started understanding the structure that we have inside of the VMC API. But I know not everybody wants to use a straight REST API. So as well as that, what we've actually done is brought out, we've integrated VMware Cloud on AWS into DCLI. So just those of you that are not aware of what DCLI is, DCLI stands for Data Center CLI. It's the CLI that came shipped with vSphere 6.0 and 6.5. It was on the VCSA. It was also on the Windows Virtual Center, and it was also part of vCLI, which is a conglomeration of various CLIs like ESX CLI, all bundled together to give you that CLI. So we kind of made this a little bit simpler because bundling all these CLIs together was a bit of a headache. So what we did is we enabled VMC to be used throughout the DCLI framework, so you can actually go to the product page today, VMware Cloud on AWS, and download the individual version of Data Center CLI for Windows, for Linux, and Mac. And this is a very simplified CLI that allows you to get up and running pretty quick and start automate some of the features, no matter what platform you're on. I'm going to show you an example of that right now and actually how you can use DCLI against this service. Anyone that's seen DCLI before will know this is pretty similar to how you would manage Center using DCLI as well. So again, I'm on my access token page. I'm going to copy my access token, and this time I'm going to go to my machine where I've actually downloaded the DCLI and extracted the zip file. You can see that I'm running a DCLI, and in this case, I'm doing a +I to tell it to go into interactive mode, and a +VMC to tell it to connect to VMware Cloud on AWS. So it asks me for my refresh token. I'm going to paste that refresh token in there, and it's going to ask me if I want to store that, so I don't need to do that again in the future. I'm going to say yes. Now I'm in there, I can actually just start typing, and it will automatically tell me what I can do throughout this CLI. You can see as soon as I go into something like orgs, it gives me a list of those areas that were in the API, every single one of those areas that was in the API, so that I can actually work with those. For example, if I wanted to do an orgs list using the short word orgs here, it will again return the information that we saw from that JSON interface, but in a nice CLI format. And we can change that format if we want to as part of DCLI. So what I did is I copied that ID for our organization, and we can now do an orgs SDDCs list and give it the org ID, and it will list it. But generally, people are assigned to one organization at the moment. So we've made a shortcut to actually make it easier for people to specify what their default organization is. In fact, we're going to use that in a second, and we're going to actually use the options, and we're going to say the option in the options for DCLI, I'm going to set a default option for org, and the value of that option is going to be this key. So the key that we got, the ID that we got for our organization. And we're going to add that to the VMC module. And now I don't even need to specify the org ID. I can literally do SDDCs list, and it will list me all of the SDDCs in that default organization for us. And when we go under SDDCs, you can see we can also create one very easy as well, and we don't need to provide the org yet again. We can actually just create a new one, and it will bring us back a task, and I've created a brand new software-defined data center, including vCenter, NSX, or the ESX hosts within one line of code. So moving away a little bit from the higher level stuff, from the console APIs and the VMC APIs, what about once we've got our SDDC deployed? What do we do then? So I'm going to take you through a little bit of a brief history of what we've done with our SDKs and our APIs in the past for Virtual Center, just to bring you up to date. And then I'll tell you where we're headed and what we're doing to bring these even more into today's modern infrastructure and how to automate and develop against those. So those of you that have been using Virtual Center for a long time will understand that Virtual Center clearly manages ESX. When we first came out with ESX, we introduced the SOAP API that allows you to manage the features within ESX. And then we had the SOAP API on top of Virtual Center, and they indeed allowed you to access the features of Virtual Center and start automating or working with those. And the way you could do that was through a number of different areas. First of all, the management SDKs. These are the SDKs that access the SOAP API and give you access in languages like Perl, .NET, and Java. We also have some open source SDKs out there as well that allow you to work with these in GitHub. So PyVMommy, RBVMommy, and GoVMommy for Python, Ruby, and Go are ways that you can use this SOAP API to automate some of those features in that language, if you are a developer that understands these languages, of course. So this was fine back in the day when everybody was working with SOAP APIs, but clearly the evolution of APIs has come to a point where REST has kind of won the war now, and REST is the default API that people expect. It's well understood. There's a lot of tooling out there. People use it and understand the models. So what we can do, and what we started to do, is actually introduce a REST API for Virtual Center, starting in 6.0 with the content library and tagging features, and then building on that in 6.5 to include new features like the VCSA API and also VM management. So clearly VM management is the main thing people want to do when they use Virtual Center. So giving that access to them as part of a REST API, and not only converting from SOAP to REST, because if you convert a complicated SOAP API into REST, you end up with a complicated REST API. So what we've done is we've modernized it along the way, re-looked at the use cases and redesigned those APIs to be the best that they can be and the easiest that they can be as well. And we brought out a bunch of tools on top of that to work with this. For example, the vSphere automation SDKs. These are SDKs that are available on GitHub. I'll have a little bit more information about these in a moment. But these manage the features that are inside the REST API and are accessible through 5 or 6 different open source SDKs on GitHub where you can actually get started with them in 5 minutes. And I'm proof of the getting started in 5 minutes because I was able to download each one of these SDKs and be up and running in 5 minutes. And if a product manager can do it, then anyone in this